In this lesson, we're going to focus on dividing radicals. Let's divide 64 by x squared, and let's simplify this example. So how can we simplify this radical? The square root of 64 is 8. The square root of x squared is simply x, but absolute value of x, since we have an even index number and we got an odd exponent as a result. Now what about this example? The square root of 50x divided by the square root of 2x. How can we divide and simplify this example? So first, we could divide 50 by 2. That's going to be 25. X divided by x will cancel. That's 1. So what we have is the square root of 25, which is 5. Now what about this example? What is the cube root of 27 a to the 9th divided by 8 b to the 6th? So first, we could take the cube root of 27, which is 3. The cube root of 8 is 2. The cube root of a to the 9, basically you take the exponent and divide it by 3. So it's a to the 3rd power. And the cube root of b to the 6 is b to the 6 over 3, which is 2. So the answer is 3a cubed over 2b squared. What about this one? The square root of 75 x to the 8th y to the 10th divided by 48 a to the 4th b to the 5th. The square root of 75, we can break that into square root 3 times the square root of 25. The square root of x to the 8, we just need to divide 8 by 2, so it's x to the 4th. And the square root of y to the 10th is y to the 5th. But because we got an odd exponent from an even index number, we need to put it using absolute value notation. Root 48, we can break that into square root 3 and square root 16. The square root of a to the 4th is a squared, and the square root of b to the 5th, that's basically 2 doesn't go into 5 evenly. 2 goes into 5 2 times, with 1 remaining. So therefore, we're going to have a b inside the radical. Now we can cancel the square root of 3. The square root of 25 is 5. So we have 5x to the 4th, y to the 5th, and the square root of 16 is 4. Now we need to get rid of the radical on the bottom. So let's rationalize it. Let's multiply the top and the bottom by root b. So the final answer is 5x to the 4th, y to the 5th, square root b, divided by, now these two will become b, and b times b squared is b cubed. So it's 4a squared, b to the 3rd power. That's the final answer. Here's another example. Simplify the square root of 36, x to the 9th, y to the 11th, divided by 25, x cubed, y to the 4th. The square root of 36 is 6, and the square root of 25 is 5. Now what about x to the 9 divided by x cubed? When you divide exponents, or rather, when you divide by a common base, you need to subtract the exponents. 9 minus 3 is 6. So this becomes the square root of x to the 6th, which is x to the 3rd. And we need to put it using absolute value. Now y to the 11th divided by y to the 4th. That's basically y to the 7th. And this is y to the 6th times y. And the square root of y to the 6th is y cubed. So on top we have the absolute value of y cubed times root y. So we can write the final answer as 6, absolute value x cubed y cubed, times root y, divided by 5. Let's try one more example. The cube root of 16 a to the 9th, b to the negative 6, c to the 5th, over 54 a to the negative 2, b to the 7, and c to the negative 8. 16 is basically 2 times 8, and 54 is 2 times 27. Now a to the 9 divided by a to the negative 2. We need to subtract the exponents. 9 minus negative 2 is positive 11. So it's going to be a to the 11th on top. B to the negative 6 divided by b to the 7th. We need to subtract negative 6 by 7, and that's negative 13. So this is b to the negative 13 on top, but if we move it to the bottom, the negative exponent will become positive. So it's b to the 13 on the bottom. And then we have 5 minus negative 8, which is positive 13. So it's c to the 13 on top. Now we can cancel 2. And the cube root of 8 is 2. The cube root of 27 is 3. Now what is the cube root of a to the 11th? This, we can break it up into 9 and 2. The cube root of 9 is 3. 9 divided by 3 is 3. So we get a cube root a squared. Now what about the cube root of c to the 13? 3 goes into 13 4 times. And 4 times 3 is 12. 13 minus 12 is 1. So we have 1 remaining. So on top is going to be c to the 4th, cube root c. And the cube root of b to the 13 is going to be just like the cube root of c to the 13. It's going to be b to the 4th, cube root times b. Now let's see if we can simplify all of this. So we have 2, a to the 3rd, c to the 4th, and then we can combine these two. So that's going to be the cube root of a squared times c divided by 3b to the 4th, cube root of b. The last thing that we need to do is rationalize the denominator. Let's multiply the top and the bottom by the cube root of b squared. On the top we'll have 2 a to the 3rd, c to the 4th, cube root a squared, b squared, c. And on the bottom we're going to have 3b to the 4th. And then let's focus on this part. b times b squared is b to the 3rd. And the cube root of b to the 3rd will become b. So this is going to be b to the 4th times b, which we can combine it as b to the 5th. So therefore, this is going to be the final answer. 2a cubed c to the 4th times the cube root of a squared b squared c divided by 3b to the 5th. Now let's work on one more example. Let's say if we have the fourth root of 81, x to the 12, y to the 11, z to the negative 3, divided by 32, x to the 4th, y to the negative 9, z to the negative 7. Go ahead and simplify this problem. So the fourth root of 81 is 3. Now what about the fourth root of 32? Well, 32 can be broken up into 5 2's. It's basically 2 to the 5th power. And if we take the fourth root of 2 to the 5th power, we can take 4 2's and take it out as 1. So it's going to be 2 times the fourth root of 2. So we're going to have a 2 on the outside, and 1 is still will be left over on the inside. So I'm going to write it like this for now. Now I'm going to divide everything on the inside first. So we still have a 2 on the inside at the bottom. Now x to the 12 divided by x to the 4. 12 minus 4 is 8. So this is going to be x to the 8. And then 11 minus negative 9 That's the same as 11 plus 9, so that's going to be 20. So y to the 11 divided by y to the negative 9 is y to the 20th power. And then negative 3 minus negative 7, that's negative 3 plus 7, which is plus 4. So this part is going to give us z to the 4th power. Now the 4th root of x to the 8 is going to be x squared. What you need to do is divide 8 by 4, you get 2. So x squared is going to come on the outside. 20 divided by 4 is 5. So y to the 5th is going to come out. And then 4 divided by 4 is 1. So z to the 1st power will come out. And we can put this within an absolute value symbol because we have an even index number and an odd exponent. Now right now we have the 4th root of 1 over 2. So we need to rationalize this. So to do that, I'm going to multiply the bottom and the top by the 4th root of 2 to the 3rd power. 2 to the 3rd power is 8. And on the bottom, we're going to have 2 times 8, which is 16. And the 4th root of 16 is 2. So this becomes 2. Or you can see it as 1 plus 3 is 4. And then if you have the 4th root of 2 to the 4, then 4 divided by 4 is 1. So you get 2 to the 1, which is the same as 2. So we can replace the 4th root of 1 over 2 with the 4th root of 8 divided by 2. So the final answer is going to be 3x squared, absolute value y to the 5th times z, times the 4th root of 8, all divided by 2 times 2, which is 4. And so that's it for this video. Now you know how to divide rational expressions and simplify them as well.